Okay, so now we're going to get started on the second part of the Chapter 8 review right here. So if I take a look at this problem right here, it says factor and use the zero product property to find the roots of the following quadratic equations. So I'm pretty much doing the same thing I was doing in the factoring problems, but now I have to use the zero product property after and I have to solve them. So I'm going to start with factoring. I'm going to go through these a little bit quicker because I did explain all of the different factoring methods in the previous problems. So if you're unsure on how to factor one of these, make sure to watch that previous video. So I know in this case, x times x is x squared. What two numbers multiply to 12 but add together to make -7? Well, they must both be negative in order to multiply to a positive and add to a negative. What would add to -7 and multiply to 12? It would be -4 and -3. So now I'm thinking about, with this zero product property concept, I need to think about what makes each of these parentheses 0, what x value. So what x value would make this 0? What minus 4 is 0? That would be +4. And in this one, what minus 3 would make that 0? It would be +3. So therefore, my two roots right here would be 4, 0 and 3, 0. When we solve for x, I get 4 and 3. So I can leave it like this. I would accept this. You could also write these as ordered pairs. X is 4 when y is 0. X is 3 when y is 0. So it's up to you how you write those. But those are my two answers, and we're going to talk in a little bit what that means on the graph. So in this case right here, I notice there is no GCF. This is difference of squares. The square root of x squared, or what times what is x squared, is x times x. The square root of 9 is 3. In order to multiply to get a negative, one must be positive, one must be negative. Now what would make each of these parentheses 0? X equals -3 for the first one, and x equals +3 for the second one. You can leave your solutions like that. If you're trying to figure out the ordered pairs of where they go when they're graphed, it's -3, 0 and +3, 0. Okay, this next one here, sorry I went out of order on this one. Again, checking for a GCF. There is no GCF with 23, so I'm going to break it down into two parentheses. This one has a few more options, 6x times 1x or 3x times 2x. 20 is 1 times 20, 2 times 10, 4 times 5. Remember, I'm going to start with this option first, not the number times 1, and I'm going to start with 2 and 10 versus 1 and 20. I can't put the 2 and 10 because if I put the 10 here, I have a common factor, and even if I put the 2 there, I would also have a common factor. So I'm going to try 4 and 5. I can't put the 4 here because then we'd have a common factor, so I'm going to put the 4 here and the 5 here. And I'm thinking about if I multiply them, I would get 8 and 15x. In order to multiply to a positive and add to a negative, both must be negative, and that works out. So now I have the correct factored form here. But now I need to know what x value makes each of these parentheses 0. So I have two ways of doing this. I either set this equal to 0 in my head and solve it, or I could actually write it down and solve the two-step equation. And I get 3 over 4, or 4 over 3, sorry. And then in this one, I could either think, well, how do I get rid of -5? I add 5, divide by 2, or I actually write it down and solve it. So there's my two answers. My two x values are 4 over 3 and 5 over 2. What that means on the graph is when y is 0, x is 4/3. And another point when y is 0, x is 5 over 2. So either way you write that is fine by me. We're going to talk about what that looks like on the graph here in a minute. Okay, and then my last one here, the factored form ends up being what multiplies to 36 and adds to 12 is 6 and 6, both positive. What x value makes this 0? It would be -6 for the first one and also -6 for the second one. So in this case, I only have one answer. I only have one root at -6, 0. And we'll talk about what that looks like on the graph. Okay, so now before we get to graphing, we're going to go over a review concept from one of the previous chapters. So this one says the price of milk has been steadily increasing 5% per year. If the cost of a gallon of milk is now $3.89, what will the cost be in 10 years? So I know this is growing. It says it's increasing. And now I'm thinking it's steadily increasing 5%. If it's increasing by 1%, that must mean it's exponentially increasing, which means it's exponential growth. So the equation for exponential growth, you put your starting value. Remember, if it's growth, we put 1 plus our rate. So 1 plus, not 5. That percent needs to be converted to a decimal. So 5 divided by 100 is 0.05. And my time is my exponent, so we're looking for after 10 years. So 10 is my exponent. And then I'm just going to go to my calculator and type that in. And I end up getting the cost will be, and we're talking money here, so it should be rounded to 2 decimal places, would be about $6.34. Now, the next question is asking something similar, but it's asking about 5 years ago. So it's asking for the cost in the past. So in order to go backwards 5 years, I'm going to have to make my exponent negative because we're going in the past. So 5 years back would be a -5 as my exponent. So I'm going to go back to my calculator and type in -5 as the exponent, and I end up getting $3.05, which makes sense. It should be lower than it cost after the fact. So 5 years ago, it cost $3.05. Now it costs $3.89, and then 10 years in the future, it would cost $6.34. Okay, next problem here, we're going to talk about graphing, and I'm going to end this video just to make this one a little bit shorter, and I will start a new video for the graphing here in a second.